Oi, oi, oi. Let's make sure all of this is working. I never really know how to start these things because I don't really do. I don't really watch other people's live streams, like on other YouTube channels. So I think it's working. Let's wait a couple more minutes for it all to catch up. Oh, yep, getting that online, which means it should be working. Sorry about this for anyone watching. All right, cool. We got sound. All right, cool. All right, cool. So we're good to go. We're set. All right. So, howdy, everyone. Thanks for watching Cheap Shot. Hoffman Tactical has been so kind as to send me his new Super AR-15 lower ahead of time to do some finite element analysis on it. Now, I'm just super excited about this because I've been kind of learning it in school, and I realize it's super easy to do in Fusion. So let's do the no support. What's the STL? Well, we'll do the step file. So let's pull up this. So here's the new Hoffman Tactical lower, and honestly, I kind of like it. One thing I do not like though is that it needs a band clip around the perimeter. I kind of don't like that, but not a band, but like a what's it called, a tube clamp or something. But that's fine. We can deal with that. So what I want to do is I want to do some analysis, and I want to see how the stresses back here react to the rest of the material. One thing that kind of sucks is I don't think Fusion 360 has PLA in here. So I wonder if I can make it ABS plastic, and if, we'll see if that works. So let's simulate. Let's just do a static load real quick. And basically that means it's a constant force. So the first thing I want to do is I want to constrain what I essentially don't want to move. And we're going to pretend that these little pinholes don't move. Oh, you put it on the inside. You know what? That's classy, Hoffman. I'll give that to you. And then we'll come over here and we'll do it on this backside too. Basically, we're just saying like this is what we want to not move. This is where it would be bolted down if it were like, you know, something that would be bolted down. And then we need to do, you know, our forces are going to be mostly, as far as I'm concerned. Can I get a screw Joe Biden? I tell you what, Drew, I'll make a screw Joe Biden for you. So join the Discord, let me know, and well, yeah, screw Joe Biden. We don't get political, but we took that rule off for today. So screw Joe Biden. Thanks for getting this video demonetized. Thank you very much for the $5. So let's take and do some already in. So let's do some static load. So we want to say load. We want to do a force. We want to do a kind of, I think, a remote force. So it's going to be acting on this plane. And if you know anything about this, by God, please tell me. I am just screwing around. So basically, it's a remote force, but it's acting on this plane, but it's back here. So really, it should technically be the threads. I'm going to do it from back there. And it's newtons, pounds force. I think someone correct me if I'm wrong. I think an AR-15 recoil has 18 pound forces. Now this doesn't really matter because, well, I'm using ABS on it. It's not sliced. We're just kind of doing a little bit of testing first. And let's see how this works. Oh, it didn't flag me. That's great. Cloud credits. How many cloud credits do I have? Can I do it locally? Let's see how it does it locally. Installing? I don't want to do that. We'll do on cloud. How many cloud credits? I've never seen this before. I've been doing this all day. But whatever. Solve one study. Save. And let's see what it looks like. So basically it'll show us kind of like a force diagram of how it's flexing and whatnot. It might take a while. I did a few other ones. Did those finish? Let's do... Yeah, it's taken kind of a while. This may not be as exciting as I thought it was going to be, huh? There we go. Sending, solving. All right, so it's working. We'll let it work its magic a little bit. Have they? Has there been a list of exactly what Joe Biden's been doing today? Like a comprehensive, easy-to-read list? Every list I've kind of seen is just things that they thought he was going to do yesterday. Nothing really exactly what it was. We're solving, we're waiting, holding patiently. I tried to do some before this so I didn't look like a complete idiot, but you know, anyone who watches the channel knows that's not true. I'm a complete idiot. God, hurry up. Let's look at this model a little bit more while it's doing that. One thing that's kind of cool is this back pin. Oh, so he expects you. I wonder if he expects you to dig your finger under there to get that pin out. I don't know about you, but sometimes I have some really tough pins. So I don't know if I'll be able to dig my finger out of some of my rifles to get that going on. Solving. Man, this is taking a while. What else did he do in here? Well, so how are we going to get that clip on there? That band. And we're just doing this while that's processing. You know, I guess one thing we could do is we could probably, oh, it's done, it's done, it's done, it's done, it's done. Results. And it's going to crash my computer, isn't it? Oh, this is great. It's crashing. There we go. Boom. So we got to load there. Oh, look at that. Look at that deformation. Now keep in mind, we're doing ABS, and this is not 3D printed. That's a safety factor. Let's look at displacement. So we're at displacement. Let's go millimeters. So this is basically saying if I were to apply 18 force pounds to the back side of this, and keep in mind, this is using ABS plastic, probably ejection molding. I haven't done anything with like actually I haven't done anything with actually like slicing it yet. We're showing some 0.048 millimeters. What's that in inches? So 0.00168 inches. And we can slide this bar of deformation. So what's deforming the least? What's deforming nothing? So basically, wherever our stress formed, we're getting a little bit of stress up here in the front and the pins. That's to be expected, right? We already know that that's going to be fine. That's where we're doing it. So coming up about a fourth of the way, we get some stress elsewhere, and we start getting a little bit of this stress here on this support. So what that tells me is that's a good thing for Hoffman's design, is if we weren't getting any stresses on there, well, this is just displacement. Let's do stress. I'm sorry. So we're getting some stress coming down. And we kind of notice, okay, so I might take back what I say, Hoffman. I don't know how much your little side profile is really helping, because we're kind of getting stresses there when we get stresses with everything else. I took that, you know? So when I'm at half of the stress I'm going to get, roughly, you know, I'm getting the majority of my stresses are forming right here on these pins, but I'm still getting nothing on your slick sleeve. So if I come up all the way, dang it, hold on, sorry. Yeah, so all my stresses are kind of here on the side and on the top with very little on the actual side, which is shocking me because that's kind of your whole thing. So I hope you don't mind this, Hoffman. Let's get rid of your slick side. Let's get rid of it. Did you design it so well that you don't need it? And keep in mind, I could be talking out my ass too. I probably am. I always am, because I don't actually, know whether or not this is even a viable thing. I talk a lot of shit, but I don't know too much. So let's take and I don't need to make this perfect. Let's get rid of your slick side. Let's extrude it out. We're going to cut. And let's see how well that works. So let's come over here to simulate. We want to simulate the same thing. We want to do a static stress. So this is a constant stress. Now, normally we'd want to do something like a recoil. I'm not necessarily sure how to do that. So we're doing this one. So our constraints, we want to do the same thing. We want to constrain on the inside of these holes. And we want to do the same thing in the front. Hit OK. Our load, right? We did a force load. We did a remote force, and we just selected those planes. How far back did we go? I don't know how far back we went, but we'll just eyeball it. This is all just eyeballing it. I mean, freak. Remote forces. We're coming back here. We'll just say 100. And what did we do? We did 18 foot-pounds. Is that what we did? Pounds force. Hit OK. Let's compare these results. This is absolutely. I'm really fascinated. Is the slick slide the slick slide not? God damn it! Does the slick side not even matter in regards to this? This is von Mises stress, first principle stress. Let's look at strain. Yeah, we've got only slightly more strain on that side support than we do on, arguably on the rest of the lower, which is not going to have any forces acting on it. That's so strange. What do you like? Drop it in the chat. What do you guys think that? Do you guys think that this side is even doing anything? If I look at just the top 50% of stresses, it's not even in there. Now that could also mean it's such a good design it doesn't need to. I don't know. What do you guys think? Drew, do you think this slick slide is even doing it? For those of you just in, we did some static stresses on the new Hoffman lower, and we realized that we didn't have a lot of stresses here. Maybe only under the push-up strength test. I love it when he does those push-ups, man. That really. Watching Chuck Norris on Total Gym? No, I'm gonna watch Hoffman on a rifle. Oh, woo! I'll buy that for $1. Yo, Hoffman, you should start an OnlyFans. So basically, we noticed that we don't have a lot of stresses here. Actually, on the stress, or unless that means the stresses on the slick slide aren't that high. So what we did is we loaded it in Fusion. We took in, we crudely got rid of the slick slide. What should I call it instead of freaking slick side? The ramp. And then we're running it again to see if it varies much. Let's look at some reports. The push-up test isn't going to push straight back. It's trying to bend such pry the print apart. Yeah, true. And it's just a general strength thing as well. Okay, cool. We're done. All right, so let's look at this. Let's look at stress. We have a 5.13, 5.123 max. Okay, so we do have, we're doing von misses as well. Oh, that's megapascals. Okay, so we do have twice as much stress without the slick side. Where is that stress? Where is that stress focused on? So what's this? This is the max is 2.248. So let's take this to roughly 2.248 and see where those stresses are going at. It's not showing us exactly where. Well, it is down here, but that's fine. We can have those stresses there. It's almost like there's not, you know, Hoffman, I don't think we need this. I don't think we need this slick side. Let's look at displacement. Well, let's look at this, 0.05185. But this can't be less displacement. Displacement total. I mean, I would need to double check that. But Hoffman, it's kind of looking like you don't need this slick side. I mean, I'd take it out. Maybe keep this little, you know, this little indent, but maybe it doesn't need to be as far as you need it to go. Maybe it doesn't need to be that far. So I think this is definitely where, and like I said, this is very unscientific. I just figured this out in some classes, and I would have loved to do some more. But that's pretty crazy. What other type of tests on this can we do? So let's start a new one. I think I could just hit new simulation body. So let's do I tried doing live simulation, right, with impacts. It didn't really work too well. So let's just constrain it from those again. No, it's not going to like that. Let's try and hit a load. Like back on this, right? Let's try and say, let's do the same thing. Let's do our 18. And let's do that result. I don't know what this. Warning. I was having issues with the plastics on this, so I don't think that's going to work with actual force loads. But this is just insane. So I'm gonna have to play around with this a little bit more. Thanks for tuning in, guys. Thanks for looking at this. But do you like analysis like this? Do you think this is worth it? Would it be worth it to maybe look at this, set up the same thing with like the Anderson or some of the other ones? Do you think that'd be worth it, guys? Because if you do, let me know, and I will do this all day long. Absolutely, absolutely. Then I think that's what we're going to do. I think I'll get back with Hoffman, and we'll plan out a little bit more about what we think we can do. Maybe he should do a push-up test on one without the slick side and one with the slick side. So who knows? All right, I got to do homework and eat some food. Do you guys have any other questions? Anything else you want to look at? I would be more than happy to look at it with you while I have it up. Otherwise, probably not this week, but probably next week, I'd probably do a more in-depth video looking at this. I might maybe talk to my professor, see if my professor wants to help out a little bit with this. That would be very interesting. I don't know if he would. Maybe once I'm not a student anymore. But we'll figure it out. All right, guys. Thanks for watching Cheap Shot. Thanks, Hoffman, for letting me borrow this before you release it. That's really cool of you. Overall, I do like it. I think that might be. I like how you have these groups with the pens. I like how you put your logo on the inside. It's your right to put the logo on there. I hate the logos. I remove them. But if I made this, I would keep yours. I'll probably make this. I'll probably start making this right now. Who am I kidding? All right. Anyway, thanks for watching Cheap Shot. Please like and subscribe. Join me on Patreon. Drew, I appreciate the $5 so much. That really helps me out. Drew, make sure you're on Discord, and we can talk about this more. Same thing with you, JH. Make sure you talk on Discord. Joey, Discord. Let's talk about this. All right. Thanks for watching Cheap Shot, guys.